Digital experience. Today it's all about tools. We've been discussing this throughout the entire week. And today we're looking more in detail what about the tool technology, what is important to consider. I'm not alone here. Here's my colleague Marius. Just introduce yourself.
Yes, also for me, hello and welcome to the DATRON Experience Days. Mark said it, today we are looking about our tools, development of the tools, what we got it here on last year and this year. And we make a small program to show you what is the benefits of the tool and yes, how does the tool working.
Right, so Marius has a very high level of competence in the tool technology, so he works at our tool grinding shop in the development of the tools. So this gives us a lot of insights of what's actually going on. So for people who know DATRON a little better, most of the tools that we use are single flute end mills. Those are not the most common tool in the entire machining market. And if we take a closer look at a single flute cutter, we can see we got this one flute. And the special thing about a DATRON single flute cutter is it's balanced. So this is USP from our side. It has a balanced cut because the technology of single flute cutters is by nature that it does not have the center of weight in the center of rotation. So there's always an unbalance which can cause problems in the milling process. That's why we have this balance cut. And like Mario said it in the first operation of this sample part, if we can get a closer look at this, we're going to make this open pocket, and we'll use another. It's a new tool, right?
So it is, yeah.
A stepped single flute cutter. So we got a shank of 10 millimeters and a cutting diameter flute of 20. So this is an extremely good tool for chip removal, for roughing operations. And let's just go over to our machine now and start this first operation. So once more, we're at the M8 Cube. We got the tool in the spindle right now. And we're taking quite of a hard and big cut here. So we're going 2 millimeter step in a full cut or a 90% step over. We're running the spindle now at 32,000 RPM at a speed of 8 meters per minute. So many people ask, what about coolant? What about how do you cool down the tools? We don't see any flood coolant here. The DATRON machines always go with minimum quantity coolant, and we use alcohol. So it basically hits the flute. It has a temperature drop of about 20 degrees Celsius when it gets out of the nozzles, and then it vaporizes immediately. So it's just a clean cut. So this is the last operation going on now, just a face milling for the following operations. And then we just take a little break here. Got a tool change. Let's come over to the table again where we can see the next tool that we're going to use. And Marius is about to tell us something about it.
So it is. So the next tool we want to show you is a combination of a normal roughing tool and the single flute end mill. So we want to combine the benefits of these two tools and want to combine that in this one tool. So we call this the DATRON cross cutter. And this is the special one of this is that we have just for the first step of the tool just a normal single flute end mill. And after that we have just a normal roughing tool. So the benefit of the tool is just have the balance of the single flute one and also have the chip breakers that gives us the chance that we have very small chips. So Yeah.
Right, the chip volume is something that we're gonna look at after we've seen it on the machine. Because if you take a close look now, the chips that this tool makes are extremely short, despite that we use a dynamic strategy. So we're going full depth, full flute length, but at the same time, just a very little step over. So we're talking about a 5 to 7% step over. And we can see the tools here, they are super short, which brings us to the chip volume in general, the process stability. Because if you have ever used dynamic strategies like this, you probably have faced the problem that you have very long chips that are like piling up and getting like big, like even blocks of chips. And the problem can be that it just gets stuck in the machine, so that it interrupts your milling process. And there was another reason for the development of these sort of tools. We have a nice comparison over, which we're going to see after the milling operation, about the volume. So it compares the volume of this cutter compared to a straight end mill. Once more, we're going at 38,000 RPM and 9,000 millimeters per minute at a step over of 0.5. Yeah, very dynamic cut here. Chips are all dry due to the minimum coolant. All right, so that's just like a bit of a kidney-shaped pocket. And let's just compare the volume of the chips of the same part. So what we have here is, you see, in this glass here, we have the volume of the parts of milling down one of these parts with the cross cutter, and right beside you see the same volume with a straight standard double flute end mill. And we can see, if we take out a few of the chips here and get a closer look at how they look. Let's just put them on the table and let's grab a few of those. So I think this tells the story. So it has multiple benefits. Process stability due to the chip length, and just a higher balance, a better run out of the spindle. So yeah, just a great tool for roughing operations. Okay, next thing we're going to talk about is like kind of micro machining, small tools, small features. And once more, let's just wipe the chips away. We have these little slots here. So the slot width is 2 millimeters here, at a depth of 4. And it's done with this tool.
So this is also a single flute end mill, so just a smaller dimension. We've got here a 2 millimeter end mill, and also the benefit of a single flute one, we've got it here. So that is the big chip channel, so we got the chance to bring out the chips very well by also the small diameter of the tool.
Yeah, right, that's a pretty essential thing. Having a large chip channel, because the expansion of an aluminum chip when it's getting cut is quite high, and because aluminum is like a soft material, so it will melt quite early, there is always a risk that the chips and the fluid get stuck by a melting chip. And you have this behavior when you have multiple fluid, like a double, triple, or quadruple end mill, especially at these diameters. Let's just quickly run this. Just got to assign a new tool here. Maybe Marius can tell us in between in the something about these features here of the pockets.
Yes, so this is a part we use this tool, so we got it here some small pockets. There is mostly the problem that we can't get out the chips, so the tool gets a heat, so it is also a combination of the tool and the cooling system. Mark said it before, just we have we're cooling with alcohol, and that is the point that we have some much problems with another end mills, and the best solution for this problem is a single fluid end mill.
Right, and now at the machine we can see the 2mm end mill making these slots. If we can get a closer look, maybe from this view. Yeah, that gives us a pretty good view. So what you can see is we're going down in a constant ramp. So we have a ramp in feed per pass of 0.8 millimeters here. And again, this is another essential, I would say, rule on our machine systems and the tools. We rather go faster with a less, or with less in feed. So we take a lighter chip, but just try to benefit from the acceleration of the machines and of the speed and the RPM of the machines. Then last but not least, after this, and if you joined the 5-axis session earlier this week, we have used, or we've made this part actually on the Tronian, and if you remember, we made these like mirror-like surfaces, and we do the same thing on the machine right now again. Yeah, stand still. So if we take a close look at this surface, yeah, there we go. Try to get this great on camera. So you see the clear difference between a surface that is milled by a regular end mill, which is this one, and a surface that is faced off with a monocrystalline diamond tool. And these tools are, they have like a soldered flute, and they are able to make a mirror-like surface. This comes right off the machine as it is here. So we just take a very, very light cut. We go in 30 to 50 microns deep per pass. Very slow. And we can see it now. It's even hard for the camera to focus on this. But we can just take the part out. See that it looks like, yeah, that's a nice reflection of the machine in this surface. All right, I think that's pretty much a good overview of different technologies. It's mostly single fluid cutters. Well, actually, we only use single fluid cutters here, just different types of. So the tool technology is at least as important as the machine itself.
So
and the combination, I think, of like DATRON, the technology of tools and the machine,
So it is,
just it's unbeaten, right?
Yes.
All right, that was the last session of the DATRON Digital Experience Week. It was a lot of fun for us to do it. I hope we were able to transfer a bit of knowledge and insights of DATRON to all of you. I'm sure we're gonna make more videos, tutorials in the future. So thank you for joining in. If you got a feedback for us, we would appreciate that. Thank you. Take care.